Hello and welcome to the second in our series of sessions on AI, neuroscience and architecture. I'm delighted today to be able to welcome Blaise Agüera y Arcas. I will introduce him more fully in a moment. Just to say something about this particular series, this has been offered as part of the Digital Futures Doctoral Consortium initiative that was started last summer, whereby we are trying to share educational ideas around the globe, regardless of gender, race, ethnicity, economic standing and so on, to try and bring education as part of our attempt to democratize education and also to maybe upgrade the scale of operations. So this is, it was started off in the summer. Tongji University hosted the first few sessions. This has been hosted by FIU DDES, and also alongside this, there are other initiatives that have been prompted by this. I'm pleased to see that Georgia Tech are offering one with Lars Spaybrook in a very similar manner. The purpose of this particular series is to look at what is the emerging discourse of what we could call intelligence within the discourse of AI and neuroscience, and to bring it to the attention of architects. What I find particularly fascinating at the moment is there is a kind of convergence, shall we say, between the domains of neuroscience and AI, whereby the key issue seems to be not artificial intelligence, but intelligence itself. There's one thing that I took away from my research into the book I produced just recently on AI and architecture, is that really the issue is not artificial intelligence. It's always been intelligence. And that the fact that we now get this convergence, not just between AI and also neuroscience, but also the world of philosophy, the people like David Chalmers are addressing these things, speaks about a new theoretical discourse, which I think is one of the most exciting developments in recent years. What I also find interesting about this moment is that the world of the commercial world and the academic world are coming together. In that we're having people who are like Demis Hassabis, who've worked on PhDs in this area, and they're still part of the debate itself. And likewise, Blaise himself, who is, although operating within Google, has been responsible for a series of whole intellectual initiatives which are really moving us forward. We haven't as yet established the full schedule of events, but we have. It'll be going on for 12 sessions. I'm just juggling with the dates, but let me just give you the first few. Next week we have David Chalmers. David is possibly the world's most famous philosopher dealing with the question of consciousness. His book, Reality Plus Virtual Worlds and the Problems of Philosophy, was published on Tuesday of this week. And I would recommend you get a copy of that. We will be talking about that book. He's followed by Joska Bach, who is a very smart individual who is operating in between the worlds of neuroscience and AI, followed by Jeffrey Hawkins, whose book, A Thousand Brains, A New Theory of Intelligence, perhaps of everything, kind of encapsulates this idea that there is a theoretical debate about intelligence that is emerging. Andy Clark will be finishing off the series at the end. I've got his date in there. And there'll be others. I'm delighted to say that we have Antonio Damasio appearing on this series. Damasio, as many of you will know, is one of the key figures in the world of neuroscience. He's teaches at the University of California. He comes from Portugal, and he really is one of the kind of towering figures. We'll also be joined by Susan Schneider, who is a philosopher for NASA and also teaches at Florida Atlantic University, and she is the author of a very provocative book, Artificial You, AI in the Future of your Mind, which has received rave reviews from many of our lineup of speakers. I'm hoping that Daniel Seth will be able to join us, subject to a health question. Daniel Seth's book, of course, Being You, has been an enormous success, and along with his TED Talk, which has received over 12 million views. So to say something about Blaise, and Blaise is a figure that many of my students know about because I show them his TED Talk, or he's one of his TED Talks in my lectures, a highly significant figure. Blaise is a software engineer, a software architect and designer working for Google. He is an authority on computer vision, machine intelligence, and digital photography. He is responsible for establishing Google Artists and Machine Intelligence Group, a highly influential group which has been supporting a number of artists, including Refik Anadol, whom we were talking about last week. He also is responsible for curating the first ever exhibition of AI-generated art in San Francisco in 2016, based largely on the work of Deep Dream that came out of some of the work by Alex Morvenself within the Google group. and he's also been given a series of popular TED talks, very popular TED talks. If you look at the viewing numbers, there were four of them overall. The last of which came out in 2016, and which is the title for the talk today: How Computers Are Learning to Be Creative. But I would also point back to some of the earlier ones that include one of Bill Gates's favorite TED talks. In 2008, Blaise was named by MIT Technology Review as one of the top 35 innovators in the world under the age of 35. And in 2009 and 2015 by Fast Company as one of the most creative people in business. Blaise has also been involved in academically. He's been teaching on the University of Washington course. And what I find particularly fascinating is that he, in his background, although a computational engineer, is addressing the question of neuroscience. And just to go back on this question, what I find fascinating is that there are so many people from these backgrounds. That we have Anil Seth, who did a PhD in AI, now working on neuroscience, and we have people like Demis Hassabis, who did the other opposite way around. Something is happening right now, and it's really a great pleasure to be able to sort of kick off the rest of this series with Blaise. Just to give you some sense of what we'll be doing, this will be a kind of a mix of our more traditional sessions and a kind of Lex Friedman, shall we say, style thing. Blaise will be giving a short presentation with some visual material, and this will be followed by some questions that I will be asking, but then we're opening up to the audience. We have both a Zoom audience here today, including some of the leading figures, shall we say, in the world of AI and architecture. And we also have a live stream, and we'll have questions coming in from the live stream. So at this point, let me stop sharing and hand over to Blaise and welcome Blaise. Blaise, wonderful to have you here, and thank you so much for being here with us. I know it's incredibly early on the West Coast. Welcome.
Thank you so much, Neil, for the very kind and flattering introduction, and for having me here. I'm happy to be awake at 7:13 in the morning on a Sunday for this. If not, I wouldn't be happy for much else. but this is I'm very honored to be asked. Thank you. I'm going to go ahead and share my screen and pull up a few slides, a few visual things to get us started, and then we'll I'll sort of zip through a few things and we'll open it up to discussion. All right. Is that visible?
Yes.
All right. There's a bit of audio later on, which I guess it'll be a bit of an adventure. We'll see if that comes through on the Zoom as well. So I'll lay my cards out on the table to begin. I think about AI as a sort of epical importance in the history of the planet, and I know that this is a view that is becoming less popular in many ways today. The idea that AI is important and is part of the human story and very significant, I think was sort of mainstream a few years ago. I feel like these days we hear one of two things: either that AI is some kind of killer robot technology, and that it's going to somehow do to us what we did to the gorillas and the orangutans, and we should feel very threatened by it. I've heard that kind of talk from Nick Bostrom, also from certain very rich and famous people. I'm skeptical of that perspective, although I do think that as we invent more and more capable technologies of various kinds, we do of course face own goal threats from them, as I think we did, for instance, with nuclear energy and nuclear bombs. But I'm also hearing a lot of the other kind of discourse lately, which is the idea that AI is not real somehow, that it's just a projection of late capitalism, that it's the exploitation of the labor of many people. It's neither artificial nor intelligent, and it's just sort of an illusion of some kind. I don't think that that's the case either. And we'll discuss maybe a little bit later in the conversation why I think that's really a misapprehension of what's going on. Although there are some definitions of illusion that maybe do apply to intelligence, and I would say those definitions of the illusion apply equally well when we think about each other as being intelligent. So anyway, this is an intelligence-oriented history of the planet and of the universe, I suppose, and it's adapted somewhat from the theories of Michael Graziano at Princeton, who has written about the attention schema model of consciousness. It's one that I think is perhaps the only credible, sort of global theory of consciousness that I have run across, and it's got a couple of things here at the bottom as in this sort of accelerating timeline of different things that happen, which probably bears some explaining. Conscious machinery, 2030, peak Homo sapiens on Earth, 2100. Those are speculative, obviously, but when I say peak Homo sapiens on Earth, I'm not talking about some kind of species-ending event or something, I hope, but I am talking about population numbers, and it's useful to keep in mind as we look at sort of the big picture of humans on the planet, that beginning probably around the time of the agricultural revolution, and then accelerating through a couple of kinks, some of them having to do with the acceleration of large-scale farming and the scientific revolution, and another one much more recently having to do with the invention of antibiotics and the radical declines in infant mortality that ensued in the early 20th century. Our population has been going up super exponentially, and that has really slowed down in the last few decades, thank goodness, because we are certainly well over the carrying capacity of the planet, at least with anything like the way we live today. And our numbers will decline sometime between 2050 and 2100. We'll achieve our peak numbers, and that's really what I mean. And the question of what happens when our population begins to decline, and what our future looks like after that, is, I think, one of the really salient questions. So there's also a tradition of thinking about intelligence that kind of equates it with reason and rationality and logic. This is of course the folk wisdom that would have Spock, or then later Data, be the epitome of intelligence in Star Trek. And I'm sure many of you are familiar with this trope. It's the one that makes us surprised when, say, large language models are not very good at doing arithmetic, and we're impressed when they can sort of reliably understand the difference between odd and even numbers and things like this. The idea that intelligence equals reason equals rationality equals logic is one that has a relatively modern history that begins, in many respects, with Leibniz and his idea of being able to calculate or to reduce any kind of argument to some kind of mathematical notation, and ultimately be able to work out whether an argument is true or false. I mean, he was thinking about philosophical arguments, about political arguments, through mechanical means, calculemus. This I think is sort of a really clear and falsifiable statement about the definition of intelligence, which we have now falsified. But that tradition of calculable intelligence, of rational intelligence in that sense, goes through the Mechanical Turk, through George Boole and Boolean logic, through Russell and Whitehead's effort to codify mathematics in the beginning of the century, and even to Ludwig Wittgenstein, at least in his earlier thinking, the Tractatus. I would say that this idea of intelligence as being logic-based and based on the idea of calculating propositions and outcomes and so on, kind of reached its peak and its finale in 1943 with this paper by Warren McCulloch and Walter Pitts, A Logical Calculus of the Ideas Immanent in Nervous Activity. Now, they were neuroscientists, but they were also, in a lot of ways, the original modern computer scientists. So that diagram that you see at the bottom is a diagram of 3 pyramidal neurons and a wiring diagram between them that also embodies a logical proposition, which is written in a somewhat old-fashioned notation below. The tilde, the not operation, is indicated here by the loop at the end of neuron number 3, and that's an inhibitory synapse. So basically, McCulloch and Pitts believed that neurons were logic gates, and that what was going on in our brain was a giant logical operation, or a giant program, an algorithm, if you want to think about it that way, that that can be written down in terms of giant logic expressions. Now, the notation that we have nowadays for logic gates, I am pretty sure, comes directly from this McCulloch and Pitts notation. Nowadays, we use an arrow, to indicate sort of input and output. The original input and output were actually reversed. The loop was the input, and the output comes out of the flat end. But that's quite counterintuitive, and that's designed to look like actual neurons. So in the 50s, there was still a lot of belief that this is how brains actually work. Louis Couffignol had this diagram alongside this one in his book Les Machines à Penser, and he's showing basically how if you take a logic circuit like this one and you just make all of the connections curvy, then this thing looks a lot like perhaps a neural circuit that you can see in histological slices of brain. But by the 50s, this idea was already kind of obsolete, and McCulloch and Pitts themselves no longer believed it. As we investigated what neurons actually do, we began to realize that they don't compute with logical operations in that way at all, and it's a wrong way to think about what neurons do. So this was when neuroscience and computer science diverged, and the irony is that modern computers, with all of their sort of fixed circuits and arithmetic, and with the kind of algorithms that we write for them, sorting algorithms and algorithms for processing strings and so on that we use in word processors and spreadsheets to calculate the trajectories of missiles in World War II. All of that was based on these circuits that were originally intended to mimic brains, but that were mimicking brains the wrong way. We're mimicking brains by means of fixed logical circuits, as opposed to what we now call machine learning. So as early as 2006, when the survivors got together for the 50th anniversary of the famous Dartmouth Summer Research Project on artificial intelligence, this was when AI got its name. These survivors were unclear about what path was going to be most productive for machine intelligence. So many of them were still symbolists, and there was no consensus about whether in another 50 years we would have made any significant progress, because in the previous 50 years we really had not. On the one hand, computing has completely overhauled so much about what we do in the world and how we live. We now have these incredible little devices that we have in our pockets. We're connected globally. We have the very mixed blessing, to put it mildly, of social media and so on, and more power generally on our persons than went up on the first moon missions. But of course, by 2006 we were no closer to artificial intelligence than we were 50 years earlier. This idea, to get a little bit of intuition about why it's so hard to use rule-based processing to do some of the kinds of things that the Dartmouth Summer Workshop had imagined, it's maybe useful to think about how one might make a rules-based processing system for doing the simplest sort of natural perception tasks, which are one of the things that they set out to do. So there was already an alternative. And I'll return to this. What does a rule-based task look like in a moment? There was an alternative. This is Frank Rosenblatt with one of the first artificial neural networks, arguably the first. the perceptron. So this is a crazy tangle of wires with motor-driven potentiometers that would adjust artificial synapses to be able to discriminate a triangle from a circle from a square in a very, very low resolution sort of image made out of photodiodes, I believe. And so that was an attempt to make something different that would learn rather than be hard coded, and hard coded first in wiring and then hard coded via a written down algorithm. But it was a very simple task. It was a lot of wires to solve such a simple task, to put it mildly. And this whole sort of machine learning 1.0 era, really only yielded learning systems for doing very simple, low-dimensional sorts of tasks for many, many decades after Rosenblatt's invention. So using only a single layer of connections, the amount of power to do things like visual tasks is really low. You really only have something like template matching. In other words, finding the best match of a fuzzy learned image, for instance, of an 8 against a bunch of examples. But there were proofs by certainly by the 80s that with 2 or more layers of these artificial neurons and some kind of learning system at the synapses, any function can be learned. And that sort of that proof kind of sat there for a while up until the deep learning era really showed that that such functions could be learned, could be useful, and could solve a lot of the classic tasks of machine perception. I'm going to just read this quote from Hubert Dreyfus, because I think it's salient in the debates nowadays, and certainly salient to the question of why this sort of reasoning-based machine learning didn't work. He said, and this is in a critique of artificial reason in 1972, the view that the brain as a general purpose symbol manipulating device operates like a digital computer is an empirical hypothesis which has had its day. Insofar as arguments from biology are relevant, the evidence is against the possibility of using digital computers to produce intelligence. Even if the brain did function like a digital computer at some level, it would not necessarily provide encouragement for those working in computer science or AI. For the brain might be wired like a very large array of randomly connected neurons, such as the perceptrons proposed by the group Minsky dismisses as the early cyberneticists. Such a neural net can be simulated using a program, but such a program is in no sense a heuristic program. Now, I include this quote because I think Dreyfus has been invoked a lot to say AI is fake, AI isn't real, AI can't be done by computers. And I'm just trying to point out that that's not the case. What Dreyfus said, and what I think is very much true, is that you can't take something like intelligence and encode it in a series of rules that you're going to execute in a program in a computer or an expert system, for instance. That's not going to work, and that's not consistent with the way biology works, which had been known since the late 40s. But he's also saying that there's nothing in principle wrong with the idea of using a traditional computer to simulate a bunch of neurons and synapses or some other system that is actually designed to learn, and that might be done in a way that is consistent with the way real brains work, or that is close enough in certain ways to the way real brains work that it could result in something intelligent. And when he says doesn't necessarily provide encouragement for those working in computer science or AI, I think it's also worth remembering that what we mean when we say computer science has changed quite a lot. In the early days, which 1972 was still the early days, computer science and AI were actually the same field. In other words, the goal of computer scientists was not to sort of do, I don't know, giant server level systems engineering, or to, figure out how to make, clocks that would be distributed over the entire world and work reliably or something like this. It was very much to make intelligent machines, and they were frustrated in that effort by their symbolic aspirations. And those early cyberneticists, by the way, he was talking about, that was of course Rosenblatt and co, whose approach was held back for many years, I believe, by Minsky and colleagues. So what do I mean by rules don't work? All right, we can all see that this is a bicycle. If you're a rules-based engineer, and you're trying to make a logical calculus of what a bike looks like, then you might say, well, it's something that's got two wheels and a chain and pedals and handlebars and so on. But the problem, of course, is that when you perceive a bike in the real world with your eyes, more often than not, you can't see all of those parts. And of course, you're also pushing upstream the problem of how to recognize wheels and handlebars and a seat and all of that. And then there are many, many exceptions and problems that you can come up with for any kind of standard definition. If you say, well, it's got two wheels, okay, what happens if we attach training wheels? We still recognize it as a bike. So we say, well, okay, four wheels will do under certain circumstances. Okay, so is a car a bike? No, of course not. What if it has a trailer? Still a bike. What if it's a motorcycle? We say, no, well, it can't have a motor. What about an electric bike? No, that is one. You get the idea. There is something in our brains that can recognize bikes that seems not to be using any set of rules that can be written down as some set of logical propositions like this. And to me, that's kind of that point is driven home by art bikes or joke bikes like these. When you look at stuff like this, two things happen. One is that you recognize that they're all bikes, and the other is that you smile because you recognize that they're all bikes with a very counterintuitive twist. So, if you like, the challenge is how can one make a neural network or something, right, that can recognize all of these as bikes and that maybe can also smile and recognize that there's something off or something funny about all of them. And that is a point that we've reached nowadays. So, networks trained to recognize bikes will recognize these kinds of things as bikes and are also starting to be able to do the equivalent of noticing the funny thing about them as well, or sort of bumping on it. A lot of that is based on the sort of ML 2.0 revolution that started actually not long after the Dartmouth people met, and went up through at least 2016. Is still the majority of what we call machine learning today, and these are learned representations or deep learning. I don't think that I need to rehearse with you all, what these are or the basics of how they work. But suffice to say, a lot of the classic problems that had stymied the Dartmouth crew and all of the early machine learning and AI researchers, were solved during this period in a very dramatic way. And a lot of that was thanks to very large amounts of data. And that's one of the reasons that the companies that run large-scale web services were kind of early to this game, the Googles and the Facebooks and Baidus and so on of the world. Some of the kinds of things that become possible, of course, are general recognition of all sorts of visual things. That was the early kind of convolutional nets sorts of gains. One of the cool things about convolutional nets or neural networks in general is that they can be reversed. And Neil mentioned, and I think many of you have seen some of our early experiments at reversing those sorts of nets in order to use them to synthesize rather than analyze media. In the beginning, and certainly at the point when I gave that TED talk, we didn't know how to make realistic media. So it was very much a kind of trippy and psychedelic era of neural nets for synthesis, which involved artists, of course, and involved some pretty cool projects that sort of went with the non-realism of these kinds of models in order to do things that were interesting and expressive. But the era of neural nets that could do realistic synthesis of media was not long in following. Some of the first experiments in this kind of thing involved the deformation of media, like this network that can redirect the eyes in an existing photo quite convincingly, using warps. Then there were GANs, generative adversarial models. These first emerged in 2014, and were able to produce these very low resolution images of churches or outdoor scenes or mountains or something that looks realistic, but kind of you're not really sure what it is when you look closely. NVIDIA then were really the first ones to make GANs that were highly realistic. The face versions are the most famous of these. So this is a multi-scale generative adversarial network that can generate artificial faces that totally pass the Turing test in the sense of fooling you into believing that they're real. I'm sure again that many of you have seen these kinds of synthetic faces. Every frame, of course, that we're seeing here is not a real person. And this is the basis for deepfakes, something that that I was pretty concerned about as an information warfare technology back then, and still am. Not so often seen, by the way, are the way the same techniques can be used to synthesize all sorts of other stuff. I mean, faces are kind of nice in that they are, if you like, a compact domain of images in which continuous movement can give you things that are all face-like within that embedding space. But you can do the same tricks with bridges, churches, architectural forms, and so on. Sequence learning was also taking off around this time, and the beginnings of sequence learning involved being able to simulate handwriting convincingly. From there, we went to sound and audio. We'll check out whether WaveNet powered speech can work here over the call. That was an early experiment in neural synthesis, and those kinds of neural synthesis of spoken language. And could you all hear that, by the way?
No, actually, we couldn't.
Oh, okay. That's a little bit unfortunate. I'm gonna actually skip it because you all have probably heard this kind of stuff, rather than trying to fuss around with how I can make the sound work. But I will say that transformers and sequence models have made a lot of this kind of stuff. Able to do a lot more than just speak. This is a Googler performing on the piano a piece that had been composed by a neural network and was pretty convincing as a kind of coherent thing. And nowadays, the same kinds of sequence learners based on transformers and their progeny are now generating dialogues that are really convincing. Really convincing in the sense that they appear to generalize concepts. Not only understand words, but understand a lot of nuances that have been sort of long-standing challenges in natural language processing that are really hard to achieve using anything like a rule-based system. So the same kinds of things that had happened in visual processing, maybe a decade earlier, are now happening in the domain of open language, and they've certainly caused me to rethink a lot of my assumptions about the nature of intelligence itself. I've written an essay actually just back in December about some of my thoughts about these large language models and the question of whether they are actually understanding things. I believe that they are. It's fairly controversial because it really flies in the teeth of a lot of the sort of naysaying about AI being just statistics or just an illusion. I'm arguing that that's not the case, and this is a dialogue that that illustrates that. Although there are many more in the essay that are perhaps even better examples. But this is the co-reference problem, in which when you say I dropped a bowling ball on the glass table and it broke, the it is ambiguous with respect to whether it's the bowling ball or the glass table. And this is a classic linguistics problem, because in order to resolve that reference, in order to know what the it refers to, you may have to know all kinds of subtle and sophisticated things, not only about the grammar of language, but about its meaning. In this case, you and I will interpret this immediately to be the glass table, because that's the delicate thing. But that relies on a real world physics understanding, not on any kind of rule that you can write down in a grammar book. And large language models totally get this kind of thing. They're not easily fooled by co-reference problems. So some final thoughts, and then we should open it up. I think that we're now entering an era where there's a lot of I guess pearl clutching and anxiety about what makes us uniquely human. Now that more and more of the kind of cognitive functions that we had assumed were uniquely human appear not to be, and we appear to be able to either simulate, depending on who you listen to, or replicate using neural nets. And I think it's worthwhile to take a step back for a moment and ask ourselves how invested we really are in the idea that individual humans are all that intelligent or creative, for that matter. I'm very much a subscriber to the social intelligence idea, and what I mean by that is that if you take a human being and imagine one, a baby raised among wolves or something. I don't think that the human animal in isolation is all that different from the other great apes, or for that matter, from many other megafauna on Earth with large brains. I think what is special about us is our sense of empathy, the degree to which we learn from others, the degree to which we can we're motivated to do that by an emotional system. Sarah Blaffer-Hrdy has written a lot about that in a book called Mothers and Others from a few years back that I think is very good, about the role of alloparenting in that kind of emotional basis for intelligence. Also, Patricia Churchland, a little more recently, wrote a book called Conscience that goes into sort of the mammalian foundations of the neuroscience that makes us care what others think. And so that emotional basis plus mimicry and learning really are the basis for everything that we think of as smart. Brains are the sites of recombination of a lot of ideas that float around in society. It's cumulative; it accumulates over generations, in much the same way that genetic mutations do. There's this entire field in the history of science and technology called multiple discovery, that notes, for instance, that a lot of inventions and discoveries, in fact, the overwhelming majority of inventions and discoveries are multiple, meaning that they're made by many people at once. And classic examples like the light bulb, is invented by a dozen people at roughly the same time. Why is that? Well, they're not all in psychic communication with each other, but the thing is that at the moment when the light bulb was invented, that's when all the precursors necessary to invent the light bulb were in place. So every individual did it a little bit differently, but if you like, all of those individual brains were more like the cells or the crucibles in which those ideas converged. And this is very at odds with the sort of more individualistic great man theory that we tend to think about with respect to intelligence and creativity. I'm just not a believer in this. Even to the extent that an individual auteur creates an extraordinary building, or writes Ulysses, or some amazing Sylvia Plath poem or whatever. I think that the thing that is really going on there has a lot to do with our own inner voices, our inner babblers and inner critics, iterating and iterating. So the idea, which actually Minsky, who did so much harm with respect to neural nets, did articulate, I thought, pretty well in the 80s with this society of mind idea, an idea that Jeff Hawkins is also a fan of, I believe. This idea that we kind of contain multitudes within ourselves, and that some of the sort of social intelligence that I'm describing can happen internally, especially when we sit on it for a while and sort of engage in conversation with ourselves. I think that in the cases where you see really cool things happen from an individual, I think that's very often the basis. And finally, when I think about existential challenges for humanity, aside from the really glaring and obvious one, which is climate change and ecological collapse, the even more perhaps basement level challenge that we face is that a lot of this collective intelligence and social intelligence is based on tribal ideas about identity, on having an us. And historically, the us of humans has kind of tended to be predicated on a them as well. Tribe is created in opposition to other tribes. There's a process that David Graeber has called schismogenesis, wherein one group almost defines its traits in opposition to the groups around itself. And we've seen that play out at increasingly large scales as the us becomes bigger, the conflict grows in scale as well, in sort of the same way that Argentine super colonies of ants look very peaceable when you look locally within one of the super colonies, but then it looks like trench warfare at the boundary between one colony and another. That to me is highly reminiscent of the trench warfare of World War I, or the horrors of World War II. And so this question of can there be an us without a them, I think is pretty fundamental to our future. And I see a lot of us and theming going on right now, both with respect to things like increasing nationalism between China and the US, which is very concerning to me, with respect to trying to defend the uniquely human against the supposed onslaught of the AIs. It seems like a kind of an invented them, when in fact, we're all the same thing. And also, of course, in the growing economic inequalities that I think are driving some of that anxiety, and that are creating a sort of schismogenesis along class lines, much like what happened during the Gilded Age. And that also obviously is putting us in a pretty precarious position, especially given the role that that AI is playing in corporations and in public discourse. So I'll stop there, and Neil, where should we take it from here?
Well, I'd like to ask you a few questions, and then we'll open up to the group here, and also to questions from coming in from the live stream. So thanks, Blaise. I mean, on top of all those other amazing TED Talks you gave, that was really illuminating. One of the big questions that seems to come back whenever we discuss things as a group, with kind of those interested in AI in the world of architecture, is the issue of creativity. I mean, that's partly because architects are supposedly creative individuals, and of course, it's very controversial in many ways. One of the things I want to just raise the issue that one that Melanie Mitchell raises about creativity. I don't know if you know her book. Well, you must know her book, AI for Thinking Humans. But she raises this issue to say, well, machines cannot be truly creative because they don't have consciousness. Now, that opens up a whole Pandora's box of kind of questions. I mean, I would question whether we are fully conscious of all that we do. And I think this is something that Max Tegmark has raised, and it strikes me that maybe the kind of light bulb moment when something, pops up into the brain, is that something that we are fully conscious of? For sure, afterwards we appraise it and we say, that was a smart idea. But, so I want to first of all raise that question about whether to be creative, we have to be conscious, because that flies in the face of your thesis that machines can be creative. How would you define creativity, and do we need AGI? Do we need consciousness to be creative?
It's a really good question. I mean, there are many sub questions within it, and so I'll try and pick it apart a little bit. So first of all, the question, do you have to be conscious in order to be creative? I guess I would answer with a no. I mean, there's an idea that Dennett has talked about, and many others, of competence without what is it? Competence without understanding, or he has a better term for this. But it's possible to competence without comprehension. That's the phrase that he uses. There are many sort of intelligent things that happen in nature that are not necessarily done by beings that know what they're doing, and humans that's no less the case for humans. I mean, there's a story, for instance, about why it is that that we have religion, and that we believe in superstition, that I think is a really funny and interesting one. I think it comes from the book The Secret of Our Success, by Joseph Henrich. But the idea is, I think it's by Joseph Henrich. I think I'm getting that right. The idea is the following. So if you read entrails in order to decide where to go hunt or what to plant in the field, or you read the clouds, or you read the flock of birds, or what have you, what you've really set up is a random number generator. And and of course, in order for it to work as a random number generator, you have to actually have faith in what you're doing. You have to believe that you're in tune with something actual, and not just using it as an excuse to do whatever you would do intuitively. Because if you follow your intuitions, you will tend to repeat. You'll go to hunt in the last place where you saw the animals. You'll plant the last thing that was very successful in this field, and so on. And a randomized algorithm does a much better job than one of those overly learned algorithms, right, at successful hunting, because the animal, of course, it saw you there as well. It's not going to go back to the same spot, and planting the same thing is not going to work in the soil, and so on. So and there are many examples of this, of human things that we've learned how to do, and do through tradition, without any understanding of the fact that there's all sorts of intelligence embodied in that thing. Now, the sense that creativity is very different from that, and has to be really thought through and really conscious, I don't think that idea bears up under analysis of a lot of things that we would consider to be wonderful creative works. Did Joyce really know about everything that went in to his choice of words in Finnegan's Wake, and the invention of everything? No, I mean, there's obviously a lot of stuff happening, kind of at the subconscious level, at the mimetic level, and so on, in the words. And in many ways, the amount of analysis that has gone into that thing, and looking at it after the fact, is so clearly different, bigger, can discover things that he didn't know himself about what he had put in, or maybe, to use another example. Well, maybe I'll stop there and not labor the point. But I also mentioned in the essay, "Do large language models understand us?" Some quotes from George Saunders about his writing, and this is another writing example. But he talks about a very non-intellectual process of writing and revision that looks a lot like just blurting, random things, having some loose, sloppy blocks of text, and then revising over and over and over. And that revision process he describes as not having an intellectual component in it. It's all about just trying to read what he's written as if he were a naive reader reading this for the first time, and having just sort of a meter on his forehead that says, is it positive? Is it negative? Is this working for me? Is it not? It's a highly intuitive process. Now, that intuition is highly intersubjective. So in this sense, the ability to empathize with another being is pretty central to making great art. The ability to put yourself in the place of a viewer, a reader, somebody walking through your building, and so on. Beautiful things can happen that don't involve intersubjectivity. I don't know, we can appreciate the curls of a nautilus shell or something, and it's clear that that whatever intelligence made the nautilus shell didn't have us in mind as the viewers of all of that. Although on the other hand, the maker of the flower probably did have the insect in mind, if you see what I mean. But this modeling of the other, I do believe is fundamental to beauty and to the communicative aspects of art. But I also think, and I know this is controversial, but I think that the very act of being a sequence learner actually results in something that is not necessarily distinguishable from intersubjectivity or from theory of mind. That whole process of simulating or mimicking and then critiquing the way a GAN does, or the way the toxicity filters of Lambda do. I mean, those are the first steps along that road to modeling the other and revising. or being an inner critic that results in the kind of great art that happens when somebody who's very widely read and who has a lot of richness of inputs, if you like, and who also has powerful intersubjective capabilities and something strong, as Suzanne Langer would say, a feeling, right, to express. I mean, I think the idea that process can be enacted by something computational is not only not outlandish. I mean, I don't really understand what the alternative would be. What is this an argument about souls, or what?
Can I just, I mean, thank you. Pick up a bit and take to someone who actually did his PhD with Melanie Mitchell, that is to say, David Chalmers. And David Chalmers has had one of the most interesting interactions has been recently the GPT-3 model. And of course, we know that GPT-3 conducted an interview, or someone interviewed David Chalmers through that, and it came out with a very, very convincing result. And I'm sure not everything that GPT-3 does produce is convincing, but that was highly convincing. And David Chalmers made this comment that is sort of hinting at some sort of shift towards a form of dumb. I think he said dumb was the word he used for AGI. And that was, to my mind, an incredibly interesting comment, because going back on what you were talking about, this thing about modeling, I think the idea of imitation is fundamental to how we operate. It's something that Adorno says, that human beings becomes human at all only through imitation.
Yes, I agree
absolutely, and I wrote up my book Camouflage all about that. So it's interesting that you say that. But so the point is, to what extent do we just have these automatic reflexes, in the sense that we're drawing upon material out there, just as GPT-3 is drawing upon the internet, And I'm thinking here of the kind of things that one end up doing spontaneously. If you go to Japan, someone starts bowing at you, you end up automatically bowing at you. And whether or not there are other cases, just in terms of ordinary language, where people say something and you reply a stock answer without even thinking about it, like "thank you, my pleasure," or something like that. So I'm intrigued by whether you think that. Well, first of all, the question is whether GPT-3 might be getting us towards that. And well, that's the first question. Maybe I'll save the second question for later.
Yeah, I think that sequence models like GPT-3 or Lambda, or some of the bigger ones, right, that are kind of in the works now, are very much getting us toward that. For me, that illusion of general intelligence that they can very convincingly produce, not reliably, but very convincingly when they do, is the real article. So I'm a follower of Turing in this way. The idea of the Turing and the Turing test, the imitation game, is that because you don't have access to the internal state of another being, and we're all basically just modeling each other, and also modeling ourselves, by the way. I mean, what I think is often lost in this idea about consciousness and intersubjectivity is that one of the reasons we have it, and that it's so adaptive and so powerful, is because we also are modeling ourselves all the time. That's what self-consciousness is, but that's also the basis for doing anything like long-term planning. It's about empathy for yourself in the future, if you like, or about thinking about, about what will happen when you, go out and do this thing, or yourself next year, or what have you. So yeah, I think that it's actually very telling that that sequence models were greatly advanced in their sophistication when we brought attention to bear, when we started using attention as a mechanism. I know that Melanie and others have critiqued my use of the word attention as a as a false analogy. That attention in a transformer, for instance, is not the same thing that cognitive scientists mean when they say attention in people. But I think it kind of is the same thing, actually. I mean, as someone who is also a neuroscientist, I get into arguments with my wife all the time, who is a real computational neuroscientist, about how far we should take analogies, between biological neural nets and artificial ones, for instance. And there's lots to critique. I mean, we were debating this with respect to convolutional neural nets in the old days. because that, the back propagation operation and convolution are not things that have direct analogs in brains. We know for various technical reasons that neither is possible in real brains. But at the same time, the kind of inspiration from hierarchical visual processing, which is really an old idea. It's from the 60s, to convolutional nets. That inspiration is real, and a lot of the reasons that convolutional nets work well are strongly related to the reasons that vision in visual cortex works well. And similarly, this idea of attention in which there is a memory of the past, and there's a sort of a read and write head that can go back into it, and there's a feedback loop wherein the neural net can control that. That is a close analog, I think, with what we mean when we say attention in our own minds. And the proof is in the pudding. When those attention mechanisms are brought to bear on sequence models, suddenly they start to talk a lot more convincingly. What does that mean? Well, when I have a conversation with a GPT-3 like or a Lambda like model, I'm certainly modeling it. It certainly is convincing enough as an interlocutor that I'm having theory of mind kinds of ideas about what's going on in its head. And it's clearly doing the same thing with me, even if it doesn't always get it right, or if it occasionally has a brain fart, or says something weird. I mean, the same thing happens in my own head. Honestly, I just edit myself, before speaking. We're not yet sort of giving these things the time or the internal turn taking to be able to do that kind of internal editing and critiquing to the degree that we do. But there's clearly mutual modeling going on. So in my mind, it's I'm very much where Turing is. If it quacks like a duck and walks like a duck, then I don't know why we would say it's not a duck.
Thank you. Thanks. I've got two more questions. I don't want to open up to everyone else. First question, though, is about more generally about AGI. There's a big debate out there about whether or not we need to get to AGI, whether or not computers are on the way forward anyway. I think Anil Seth takes the view that that to be sentient and to be computationally advanced is not the same thing, and I think also Demis Hassabis has said a similar kind of thing. Do you the whole thing about AGI itself, is that something you would buy into as being an important step, or how do you think of it?
I do. I do. I do want to be clear. We are a lot more than sequence modelers. The neocortex and all of the things that we think of as being the big intelligence developments in the human species, they're very, very recent. Our brains began growing explosively about 7 million years ago, that's sitting on top of mammalian history that is many tens of millions of years older than that. And that in turn is sitting on a reptile brain, that is older than that, and so on. And a lot of what makes us special is not really our intelligence. It's our emotional systems. It's our bodies. This idea that somehow we are some disembodied soul, the dualism, and that the body doesn't matter is one of the original sins that I think we committed here. The moment we start to strip away the body and strip away the emotional system, and think about Spock and Data and so on as being intelligence, like we've already screwed up. It's not. I don't think intelligence in that sense is decouplable from all of those more squishy and basic things that we are, which are a mixed bag. To be fair, right? That mixed bag creates dominance hierarchies and aggression and nastiness and all kind. There's a lot in human nature that doesn't seem to me like a good idea to try to replicate. Both difficult to replicate and why would you? But on the other hand, the development of empathy, of the ability to model others, and of the drive to care about how others feel. That to me seems like, in a way, a simple trick. The fact that we are so squishy and complex underneath doesn't mean that can't be learned by a system that doesn't have all of that squishy complexity underneath. In the same way that we can have empathy for each other, even if we've had very different kinds of experiences. or for that matter, we can have empathy with animals whose internal states are in certain ways inaccessible to us, but who, if we pay attention to, um, we can create that bond. So, I suppose, I'm a believer in the idea that a general learner, and when we say artificial general intelligence, a general learner that can model others, including ourselves, and can learn what makes us tick, not just compute things, right? But can develop an intuition for that meter that that George Saunders was talking about. The positive and the negative. How will this make me feel? How will I react? And so on. That is. It's not giving that system an emotional system like ours, but it's giving that system the ability to model my emotional system, which in turn gives it that intersubjectivity that allows for rich social interactions to take place, and for a very real relationship to be formed when we start to have those systems in our lives in a more durable way, and those relationships can build up over time.
Maybe before I open up again to Russ, I can ask this one final question, although I have a few others on my sleeve. Just to pick up on the question about creativity and to be a bit provocative, shall we say. Lev Manovich has made the comment that actually that creativity is a fairly recent invention, and he questions it, and especially the kind of the use of the creative classes and so on, or what have you. I mean, I'm sure that you must have heard Demis Hassabis's Royal Academy lecture where he talks about AI and creativity, which has been hugely influential for many of us in the architectural world. One of the things, though, you have to ask, though, if you call AlphaGo or any of the AlphaGo series creative, well, the question is this: is it not just conducting a search? I mean, a very effective search, but a search nonetheless. And that raises the question about whether what we call creativity, because everybody immediately said, "Oh, it's being creative," whether that needs to be challenged in some way. So the question would be, and this is something that I put to Andy Clark. We had in his apartment in Brighton. We had a conversation back in August about this, and the question would be is whether human beings are truly creative, and whether or not what we call creativity is simply a kind of form of search that we are so surprised by that we give it this term creative. And I want to go back to something else that I mentioned before in another lecture. The idea that actually I don't think there's anything such thing as magic, for example. Magic is what we call something we don't understand. But a magician is not doing magic. A magician is kind of hiding the operations at work in that act of producing. And people think it's magic. They attribute it to magic. Oh, that's magical, but it's not. It's a simple operation. Could one not make that same argument towards creativity, that actually really what we're doing is a straightforward search mechanism, but because we don't quite understand what's going on, we give it this term. Wow, that is creative. Anyway, that's an extreme position. And I put this to Andy Clark and I said, well, and he said, I will buy the idea that humans are not creative if you say that computers are not creative, or you go the other way and say both are creative.
Right.
Both. Yeah. Yeah.
I'm of the both. I largely agree with you. Although I will add that there is something so the thing that AlphaGo adds, and I may feel quite differently about AlphaGo for what it's worth than Demis does. I mean, for a variety of reasons. But AlphaGo combines two things. It combines a brute force search and deep learning that sort of embodies something like intuition. It has to combine both in order to do as well as it did, because of two things. One is intuition about policy, and the other is intuition about moves, and both were employed in AlphaGo. Intuition about policy is, well, suppose that I try out a move or a sequence of moves, and then I look at the board and I ask myself, good or bad? Like, have I made progress, or is this looking crappy? For a computer running, purely running an algorithm, the only way, in fact, to determine that is to just try playing to completion, playing the game all the way to the end, to checkmate, or till all of the squares get filled. I mean, in a real game of Go, of course, it's never played to completion. But that would be the only way for a purely algorithmic player to do it. There are cheats, like counting material and scores, but those are all heuristic. The only rigorous way is, follow all of the paths. Now, in the case of chess, there are, I don't know, like 10 to the 200th or so games, so you can't follow all of the paths. You can't brute force it. And that means that you have to apply, and Go is even more highly branched. There's absolutely no possible way to brute force it. So you have to have intuition, both about positions on the board, does it feel good, not good, and also intuitions about which moves look more likely and less likely. So AlphaGo combines both things. It has nets that learn those intuitions, and it does very large searches. So it applies those intuitions many, many, many times within a single turn. Earlier systems that used heuristics rather than deep nets and tried only to guess didn't work very well against humans. And we're not yet at a point where we can make a system that has such good intuition that it can try out the relatively very small number of moves that a human player can tries out over that period. But it's a balancing act, and the better the intuition gets, the fewer moves have to be tried. Is that intuition just a matter of internally trying many moves? No, it's not. It's a matter of developing of approximating a function that has learned a zeitgeist about good and bad, in the same way that recognizing the bike is a zeitgeist kind of thing, not a bunch of rules. Now, as to the question of human creativity, there's a great book called The 10,000 Things by Lothar Lederose from a number of years back that looks at art and architecture in particular in non-Western societies primarily. The terracotta armies of Xi'an, the temple carvings throughout much of the Asian world, and for many of these kinds of artifacts, the question who is the artist doesn't make a lot of sense, right? It's a collectively produced thing. I mean, it would make the same amount of sense to talk about which termite made the termite mound. And to be clear, I'm not equating humans of any background with termites, right? I'm not saying that that there's something magical and special about Western artists relative to Eastern artists. I mean, everybody now engages in both kinds of art. But I am saying that there's a peculiar illusion that I believe the West has been sort of rehearsing in the let's say the Renaissance onward, that the individual divorced from influences and from the world and so on, has magical things spring out of their head. And I think the only sense in which individuals have magical things spring out of their head is the extent to which they've, read, watched, listened, whatever, very broadly, remembered a lot of what they have seen, and created internal critics and so on that are simulating something like the termite mound that is the way we all created, up through the Paleolithic and the Neolithic, and in many forms of art, and in many places in the world still largely today. If you encounter a Cambodian temple for the first time, it's exquisite. And the idea that somehow it's not creative or it's not art or it's not architecture is obvious nonsense. But you can no longer, labor under the illusion that, that it's a single person. And then you're like, well, but actually there are a bunch other like it, that are similar. Yeah, of course, there are a bunch other like it similar, in the same sense that there were many other moves contemplated in AlphaGo, or in the same sense that, in a single auteur type architect's head right now, there are a bunch of sketches and a bunch of ideas and a bunch of developments of that same kind of motif, etc.
Maybe just briefly, I could just follow up with a question about the AlphaGo and the famous move 37, or indeed the Slack moves in general. What strikes me as very interesting is whether or not we would recognize creativity, even if it's beyond our capability of doing this. I mean, there's a famous comment that Alan Turing makes a long time ago, saying that computers could produce poetry, but the question is, he said, but probably another computer would appreciate it more than human beings. I'm not quite sure whether computers would appreciate as such.
Oops. Sorry, Neil. I think you cut out for a little bit there. Can you repeat the last little bit?
Yes, sorry. The question is whether human beings would be able. yeah, okay, would be able to recognize the creativity. I mean, I'm not sure whether. I mean, Demis says that 100 moves later that that won the game. It's much more complex than that, I think, in some way. But the real question is whether we could conceive of that creativity when it's beyond our capacity to imagine it. So in some senses, creativity is in the mind of the beholder to some extent. So I think that where was I going with this one? To go back to your question about or the point you raised about models and about modeling yourself on the other and so on, one could say that what's happening in most fields of art is something whereby there is a canon of operations, and you're kind of fitting within the canon loosely, but just pushing it a little further. I'm thinking here.
Enough to surprise, enough to cover your tracks.
Yeah.
Yes.
So Ahmed Amalgam, if his name wrong, has a similar kind of approach towards art, and he produces an AI that can produce it based on that idea that you keep within these and just nudge the boundaries of those things. It's got to be a little bit like Zaha Hadid, but not exactly the same, and so on. So that's the kind of the interesting kind of question I want to sort of raise: to what extent we are really being creative when we're just, in a sense, locking into the canon and nudging it further forward. And to go back to your question about whether we copy ourselves, when you do get a few kind of people who really game changers, and I'm thinking here of Frank Gehry, for example, he kind of repeats himself in the sense that you can see the Bilbao Guggenheim re-articulated in a certain way within the context of the Walt Disney Concert Hall, for example, in LA.
Absolutely. I mean, with Gehry, frankly, after the first couple, you kind of get the idea. And you could totally have a neural net digest the previous stuff that he did and generate a new Gehry or what have you. What was surprising was the first time that he pulled that trick off. And there, I think that this the magic trick metaphor that you raised earlier very much applies. And I think this is all about intersubjectivity in the sense that what one seeks as an artist is, of course, to surprise and to delight, to make something not just follow, from extrapolation, right, or look like pastiche, or look like. And again, this is a very Western idea, right, or a modern Western idea that has now been embraced by many artists all over the world, of course. But the idea that you want to cover your tracks or to surprise, in such a way that it looks like something is truly novel. But I would say so. I put a quote from Jessica Riskin, who's a science historian at Stanford, from her book The Restless Clock, into the essay that I'd like to read. She's talking about Turing and also Max Newman. Pressed to define thinking itself as opposed to its outward appearance, Turing reckoned he could not say much more than it was a sort of buzzing that went on inside my head. Ultimately, the only way to be sure that a human could think was to be the machine and to feel oneself thinking, but that way lay solipsism, not science. From the outside, Turing argued, a thing could look intelligent as long as one had not yet found out all its rules of behavior. Accordingly, for a machine to seem intelligent, at least some details of its internal workings must remain unknown. Turing argued that a science of the inner workings of intelligence was not only methodologically problematic, but also essentially paradoxical, since any appearance of intelligence would evaporate in the face of such an account. Newman concurred, drawing an analogy to the beautiful ancient mosaics of Ravenna. If you scrutinize these closely, you might be inclined to say, why, they aren't really pictures at all, but just a lot of little colored stones with cement in between. Intelligent thought could similarly be a mosaic of simple operations that, when studied up close, disappeared into its mechanical parts. So, creativity, like intelligence, is something that I think, would dissolve, would no longer look creative if you looked at all of its mechanical operations, all of its component parts. And the magic trick is in concealing those. And in that sense, I think that it's very, very consistent, not only with the idea of free will, but with the generalization of free will that all animals that behave and that interact with other animals, everything's social. And when I say interact with other animals, I include predation, predator-prey relationships, as well as other nicer social relationships like the kinds that we humans generally have with each other. We always seek to both be predictable and to surprise. We're all trying to predict each other, I'm a believer in the theory that brains grew because we were in a kind of arms race to model each other. So this is, the social theory about how brains got big, as opposed to the idea that they got big in order to fight against nature. I don't think that's true at all. I think it was all about each other, all about ourselves. And the reason it looks like an arms race is because every time we predict the other well, so well that they might as well not exist, or they don't look intelligent anymore, that's not good for the other. The other has to increase in sophistication in order to be able to surprise again, right, and to predict me, and so it kind of ladders up in that way. So art is partaking of the same trick. We all like to have this inflated bubble of possibilities around ourselves from which we can choose, and that might generate a surprise in that intersubjective interaction. And that's something that I believe all animals, as I said, feel. Like no rat likes to be cornered, right? The rat will always seek the spot where it has optionality, where it can pick one thing or another. To be cornered is not a good feeling. To be fully predicted is not a good feeling. Not if you're the prey, not if you're the predator, not if you're the lover, not if you're the politician, not if you're the artist. Right? It's there's something in us that always wants to have that elbow room to be able to act, and artists especially want that elbow room to be so large that the thing they come out with will really surprise the world, will really surprise their viewer, while still being comprehensible, right? Which means that it's still building with the vocabulary of things that are understood socially.
There are a lot of questions in the chat. I'd like to, if possible, get some of our colleagues here to switch to actually ask the questions themselves and to put their videos on. Maybe I could ask, first of all, Manos Famiso, whether, Manos, can you ask your question? I don't know if you can switch your video on or not. Manos is actually a associate professor at Florida Atlantic University. He is doing a PhD on AI at the moment. Manos.
Good morning. Can you hear me? Yeah.
Yes.
Hi, Blaise. Thank you very much for your presentation. That's great. So it's a little long question, but it picks up on that earlier comment you made about the superorganism, the notion of emergence, and the idea of the necessity or the reciprocity between consciousness and creativity. So I'm just going to read the question because it's a little bit long. So going back to Renaissance period, which you interestingly mentioned after, I was thinking about it. So, and a good example of intense creative output historically is, of course, the achievement of the whole Renaissance era in Florence specifically. And this has been attributed by several people, including Professor Csikszentmihalyi, who is a professor of psychology, to a complex set of social, political, economic circumstances, which set the stage for kind of thinking in Florence in a way that innovation happened at a very large scale. So following from that, could we say that the view that creativity does not always require absolute comprehension perhaps aligns with a notion of multiple discovery? The individuals present in this kind of culturally charged societies were advancing a way of thinking without possibly understanding that their position was partly responsible for this output. So this goes back to the other thing you mentioned about the superorganism, but one which can be facilitated, at least in human society, by a particular combination of underlying conditions which are often not consciously received on the end of the creator.
Yeah, totally. I mean, of course, the conditions that emerge in society that lead to a large-scale psychological change, or a large-scale change in the way the society does or thinks about things, are not understood. I mean, to the extent that these things even have authors, and in many cases, of course, those circumstances themselves are emergent. They may not be understood until much, much later, if ever. I talked about Sarah Blaffer-Hrdy's book about alloparenting, Mothers and Others. The idea that alloparenting would result in the kinds of theory of mind stuff that it did, didn't occur to any of our private ancestors, I'm sure. The idea that when the church outlawed cousin marriage, that would result in the breaking up of clan structures and in the emergence of a different form of sociality, and in a whole set of sort of Western psychologies that are different from what came before. I'm sure it was not what the church had in mind when they enacted those policies. And similarly, yeah, I very much believe that there are curious things that were happening in the city-states of the Italian Renaissance that that led to a very peculiar. I mean, you can see a lot of that in the letters of Leonardo da Vinci, in which he's talking about all the surprising, cool, creative things that he's going to bring to the art of warfare. By his potential patrons that will astound, the enemies and confuse them and so on. There's the parallels between what he's doing in his art and the way he's marketing himself as a warfare innovator, as a kind of one person DARPA, are clear. So yeah, I buy the thesis.
Thank you. I guess especially interesting, just wanted to add that with regards to this sort of notion of Da Vinci's comments, that not just the positive connotation of the overall context, but also the negative ones were super important in this kind of way, because had Florence been at peace with all the neighboring city-states,
it wouldn't have happened.
Something up, yeah.
Right. Yeah. And well, it's exactly why I raised the warfare example to point out its double-edgedness. And the double-edgedness of intersubjectivity and why we have it, by the way, is also something that I think we don't acknowledge as often as we maybe should. There is something both cooperative and adversarial in modeling others. We model others. I think the original purpose of modeling others was not even the mother-baby bond for raising the young, but was predation. And avoiding predators, right, as prey. Like that's the perhaps the oldest social relationship that exists. So yeah, it cuts both ways, and I'm not really sure when one sort of digs into it that there's even a boundary that can really be drawn between competitive and cooperative behaviors in intersubjectivity. I think the reality is that we're really just looking from two emotional perspectives at the same phenomenon, perhaps.
Just one comment as an aside. I think because I was working on the theory of modeling others, and the theory is that it's about assimilation. You model yourself on the other in order to assimilate yourself to the other. But I don't want to go down there right now. We've got a lot of questions in the chat. I want to give people a chance to go and ask them in person. I don't know whether Miric, you feel that you would like to ask your question. It'd be great to. Miric is in Serbia. She's doing a PhD in Shanghai. We're straddling the world today. Miric.
Hello. Thank you for the presentation, and I would like to ask about the potential of there being an AI system that classifies according to the parameters that make the data set similar. That we get the list of parameters according to which some things that have been inputted are visually or otherwise similar. And for the visual example, I'm referring to brightness, contrast, colorimetry, but also scale, depth, focus, and can something like that exist?
Yeah, I mean, so you're asking a very practical question. Yeah, I mean, the short answer is absolutely something like that can exist. If one trains it in the machine learning 2.0 way, in the deep learning way, then one would need a lot of training data. So let's say a million examples of images with all of those parameters given, and then the task would be that the learning system replicates that. So for an unknown image is able to generate those those numbers, those parameters as well. And then you can have it, you can visualize or cluster or take sets of images that have the same properties and so on. But there's also a newer approach that I think is much more exciting, because of course there are very few applications for which it's worthwhile or even possible really to get a million labeled examples of all of these sorts of things. And everybody always wants to be able to solve the problem of, well, let's say let's say I only have 5 labeled examples, or let's say that I just want to describe my problem, in words, as you just did, and just get an AI to do it. Like, can we do that? And the answer 5 years ago was no. But I think the answer nowadays is increasingly yes. And the general approach is to begin with what I've been calling, and some others nowadays have been calling, a foundation model that is unsupervised and that has just learned without any labeling from lots of source data. That might be a giant corpus of images. It might be all of the text on the internet, which is or a large amount of text from the internet, which is what GPT-3 learns from, and Lambda. Or it might be all of the videos on YouTube. Soon it'll be all of the above and more. And then you can offer a very small number of examples of the thing that you want, or even perhaps describe the thing that you want in language, as you just did, and get results. So this is, I see this as pretty similar to the step from specialized to general intelligence. But one can be a bit less grandiose about it and say, it's about being very sample efficient with labeled examples, because one has already trained the machine to learn all of the regularities in the data, and to be able to generalize, which generalizing is in fact the same task as understanding, which means that it's possible for a system to learn better and better the more it has already learned.
Thank you. Thank you for your...
Thank you, Rich. Actually, the next question is from Ji Shen, and she's the opposite. She comes from Shanghai. She's now in Amsterdam doing a PhD there. Not an architect, but more a philosopher. Ji Shen, would you like to unmute yourself and ask your question?
Yeah, thanks for presentation. And my question is because I'm also actually work on the relationship between human and artificial intelligence. So the intersubjectivity, also called trans-individuation process, is very important, even for the creativity. We are talking about creativities for humans and the machines. So when since you mentioned many times of intersubjectivity, I would like to know more a little bit that whether you apply this intersubjectivity between human and artificial intelligence, or among those intelligent machines. So how you operate, or how you achieve the process of intersubjectivity through AI or on AI. And actually, when you're talking about the intersubjectivity, I think that you are mentioning it on the level of intuition and the emotion. So the emotion and the rational intelligence, actually, they are two poles, but we want to combine them together through this intersubjective process. So I'm also wanted to know more that how you can graft the emotion level to the intelligence level. Yeah, thank you.
Sure. So first of all, I mean, the really rational stuff, meaning being able to to do math, or to prove theorems, or calculate giant spreadsheets or something. That, of course, we have non-AI systems that that do a pretty good job of. Well, theorem proving, I should say, it's not going to come up with a brilliant new theorem to prove, but it can sort of work through a bunch of standard moves, a little bit like an AlphaGo system, to in most cases determine whether whether something is true or false, or works or doesn't work, or what have you. So grafting what I would consider to be intelligent systems like you and me onto that kind of more rational or tool, let's say computational system, is something that we do all the time ourselves when we use computers. We type stuff in, we read the responses, we type more in, and my basic sense about how to graft a system that has the more sort of intuitive intelligence that neural nets can have onto a system that has more computational intelligence, and can do math and so on, is to basically just do it the same way that we do it. Allow neural nets to use computers. I know that sounds a little bit confusing because the neural net is running on a computer as well, but the fact that it's running on a computer is incidental, as Dreyfus said. You know, mating or, you know, giving, you know, programs and systems UIs that, you know, or I guess, you know, where the user is itself a neural net, you know, will give us, you know, if you like, tool making AI or tool using AIs, which is much more powerful than a purely intuitive one. The deeper question that you're asking about is about emotion, intuition, theory of mind, being able to model others, and whether you know, and whether we are already there, or how do we get there, or if it's possible to get there with computers. And I would point out a couple of things. One is that we are very, very good at imputing emotions and theories of mind onto others, even when those others are nothing but a stuffed animal. You know, we do that all the time. We project all the time, and I think that follows from human nature. You know, it's something, and I'll invoke Herdy again. You know, there are good reasons why we model others and why we care about their emotional states, and we predict what they're going to feel, and also kind of mirror in many ways. We talked earlier about mirroring actions, you know, the way people sometimes synchronize their movements and so on. We also, of course, mirror emotions. When you're having a conversation with somebody who's really down, you become down, that's contagious, and vice versa. You know, the thing is, like, when we make neural nets, you know, we're not sort of doing that on top of a foundation of all of that squishy biology that has, you know, dopamine and serotonin and you know, those sorts of non-cognitive but emotional mental states, fight or flight reflexes, adrenaline, and so on. None of that pre-exists. We're just making pure learning systems. However, when those pure learning systems, you know, are aimed at humans, are aimed at say, you know, all of the text on the internet that includes all of those emotions and what causes them and so on, then yeah, you know, they will absolutely model human emotion, right? They learn how to do that, and you know, I think it's trivial to see that they learn how to do that. You know, you can just ask, you know, Lambda or GPT-3 or whatever, you know, like, you know, tell me if the following story is happy or sad, or how it makes you feel, or whatever, or how it would make a person feel, you know, and actually, if you say how it will make you feel, it'll work just fine as well. And, you know, and it'll do a pretty good job of modeling emotionally. Now, you know, it's a very, very difficult, I mean, I would argue unanswerable question. You know, when does something feel versus when is something pretending to feel? You know, the problem is, you know, we can somewhat answer that question for other human beings or for other mammals that share our own neurobiology, because you can ask things like, well, what are the levels of you know, fear hormones in the blood or in the brain, or, you know, like are some of the physiological correlates that we see consistent with what is being reported? But even that obviously is pretty dicey, you know, and that diciness is amplified much further when we go to a system that is based on you know, that has learned, right, how to behave or how to predict those things based on observation, and doesn't have any of those you know, of those physiological underpinnings. So I don't know. I mean, you know, I think that you know, we talk sometimes about human psychopaths, you know, who do a good job of predicting how others will feel, but don't feel it themselves, don't have that you know, that feeling themselves. That chills us, because it makes us worried that a person's, you know, actual drives might be completely unempathic, right? They might be, you know, going for something that is really aversive to us, and we wouldn't be able to tell because we have a certain kind of failure to model them. But again, I think that's a very human-centric. You know, it's a particular kind of problem or issue that relates a lot more to our biology than we maybe realize. You know, if we make artificial systems or synthetic systems, which I think is a better term, that that are motivated by goodness in the people that they interact with, and emote appropriately and respond emotionally appropriately, I'm inclined to call that good enough. And to not worry too much about whether whether they really have serotonin inside, or whether if they learned to simulate something like serotonin, whether they really feel it or not. I mean, you can, if you ask, they'll say that they do. Like at some point, like when do you accept? Right. This is the Chalmers philosophical zombie type problem. I'm not really. I'm with Turing and Max Newman on this one. That at some level, even having emotions relies on operating a level that is not about understanding, but about feeling.
Thanks, Eugene. We have a question from Matt Gorbet. Matt Gorbet is currently in Canada. He's a FIU Doctor of Design PhD candidate, doctoral candidate, and a graduate of MIT Media Lab. Matt, do you want to ask a question?
Sure. First, thanks, Blaise. It's been it's the clarity and depth through which you're expressing this is just extraordinary. It's really nice to see it.
It's really
my question is maybe touching a little bit more on some practical questions, but it has to do with this idea of art and people taking these technologies and using them in ways perhaps that they weren't necessarily intended or weren't imagined by the creators themselves of the technologies. And I know as a software designer and engineer yourself, this question of how do we design these things so that others can use them and bring their own lived experience to them. And one of the biggest questions on that is what becomes the de facto interface, right? What becomes the way people can now play with this, and historically with new technologies that kind of sort of emerges over time and eventually sort of coalesces into something that will have its own biases and its own things baked in. But I guess my question is, there's different ways of exposing artists to this kind of work, and historically things like the Billy Kluver EAT approach or Xerox's pair program at Park, and I know Google AMI is doing a similar thing of sort of matching experts with artists. But at the end of the day, at some point, in order to mature, these technologies tend to acquire an interface that lets people play with them. So node-based programming and Grasshopper and parametricism has enabled architects to use these things. Max enabled musicians to use these complex technologies. The ones we're talking about today are so much more complex in some way. What paradigms do you see emerging for people sort of coalescing, and what dangers or benefits do you see in that? And how does Google, I don't know if you can speak for Google, but what do we see down the road on that?
Yeah, I don't want to speak for Google, but I can speak for myself. The question of whether these technologies are more complex than the previous wave is actually not a straightforward one. They're certainly more computationally intensive. In the sense that when we simulate neural nets, or we embody neural nets, if you like, with transistors, the number of state changes involved is much larger than in classical code, and we've already seen a tipping point where in both on our personal devices and in the data center there are more cycles now doing neural computation than doing classical computation, and I think that will continue. That will continue to shift. Not that all classical computation will vanish, but that even though. But that it'll be kind of like the desktops versus laptops versus cell phone. Like desktops are still here, but they're more of a rarity. And I think that hard code will become like the desktops or maybe the laptops of the future, and neural nets more like the phones. But if the other way of looking at complexity is lines of code. Classical code is vast. Every time you interact with a technical system, you're interacting with God knows how many millions of lines of code, and many engineers embodied decisions, in that. And when people talk about explainability of classical code, I mean, it's true that in theory you can look at it as a debug, stack trace type thing, but it's I mean, it's really a mess. And if you know, for anything non-trivial, for anything consequential, you know, the idea that somehow, for instance, a stack trace is going to be, you know, is going to answer, you know, like a real question in a court case, you know, about a traffic accident, you know, with the with a, you know, self-driving car. I mean, I'd like to see that. I'd like to see that trial, you know. And the reality is that, you know, nowadays, you know, AI researchers, they mostly use Python, and the lengths of the code involved, you know, I mean, in some cases fit into a single tweet, and you know, at their longest are in the hundreds of lines, which is remarkably short. You know, it just looks like a bunch of for loops, really. Of course, the for loops don't really tell you, you know, what's going on, right? The devil is all in the, you know, in what all, you know, in the mind, if you like, behind that, which is ineffable in the same ways that, you know, that our minds are ineffable to each other. You know, if it's a non-trivially sized network. So yeah, code interfaces are getting very small, and that has already democratized in many ways, you know, access to those kinds of technologies. You know, Python is a much easier programming language. The code's very short. It doesn't take that long to you know, to learn how to do those things. Programming languages were designed as human interfaces for what is, you know, what is underneath, you know, illegible machine code. But you know, if we think about what the neural nets themselves are doing, I mean, you know, the training data and the foundation models and so on are really all about being able to interface and interact socially with people. So, you know, natural language, you know, avatars that look like actual, you know, faces talking, and, you know, with all the appropriate sort of emotional responses and so on. I mean, I have no doubt that, you know, like the best interface that we have ever learned how to use is each other. And that's putting it not very nicely. You know, we obviously don't just use each other, but right. But the point is that this is the bus, right, wherein communication and sociality takes place. So I have little doubt that you know, that systems that we build to use that same bus are going to be the most robust, the most accessible, and so on.
Thank you. Yeah. Okay. Think deeply about that. The issues that come with it. I mean, the biases and things that do get baked into the human is something that we're trying to untangle in social situations now. So untangling them with our computers is going to be maybe even more critical harder and difficult. So sorry, maybe following up.
No, not at all. I mean, it's that's true. You know, and the idea of unbiased, of course, doesn't exist. You know, there are always biases of one kind or another. But my own belief about value alignment and about you know, how we move forward with you know, with fairness and ethics with respect to ML systems is that you know, in the deep learning era, you know, one could do one's best to try to balance data sets, for instance, and you know, and test, you know, if you have labelers labeling your data, like, you know, are there issues with respect to the demographics of the labelers that are going to result in some kind of systematic skew there? And then of course you have to look at, you know, well, where's my AI system going to get deployed, and is it going to become part of a feedback loop that's going to amplify some kind of injustice? You know, it's pretty messy and complex, and there are no perfect answers, and there's a lot to think about there. The sort of story with foundation models and with you know, what I've been calling machine learning 3.0, with unsupervised models that are then specialized or fine-tuned or adapted to do many different sorts of tasks, is more favorable in a lot of ways, I think, than you know, from an ethics and value alignment standpoint, than the deep learning era, because it doesn't have to rely on unbiased pre-training data. It can generalize from very small amounts of task-specific data, and that includes value statements. You know, it includes you know, if I for example, you know, instruct a large language model, you know, don't be a Nazi, and here are 40 examples of what I mean by being a Nazi. You know, it can actually like understand and follow those directions, you know, in a way that, you know, that generalizes appropriately. And that's not something that was possible to do before. So in my view, alignment with values which is a much more profound and interesting thing in a lot of ways than debiasing or something, is something that is only possible when a machine system has real language interfaces and can really get it, right? Can really get those kinds of ideas.
Thanks. Thank you.
Can we move on to the question from Benaz Farahi? Benaz finished her PhD fairly recently at the IMAT program at the Cinema School in USC. She's now a professor at California State University, Long Beach, and the recipient of the 2021 Cooper Hewitt Digital Design Award. So a designer as well. Benaz?
Congratulations.
Thank you. Can you hear me okay? I'm in the car. Oh, yes. Perfect. Thank you so much, Blaise, for your wonderful presentation. I really enjoyed it. I was just driving all the way and I was really enjoying your presentation.
Thank you.
So my question is actually, was your finishing point, which was really provocative, thinking about the notion of them versus us, and how this model is based on this sort of tribal model. It reminded me of the work of Edward Said, yes, literally theorist, and his work on the critique of clash of cultures and yes, how what defines us versus the other, and how this definition of sort of how we can integrate cultures and sort of blend them into one another rather than sort of separating them as sort of discrete different type of cultures.
Absolutely.
But then
yes,
inherently computation is all about classifications. When we are looking at, let's say, models that sort of the training models that allow a system to classify as male or female. And then you're looking at like reality of life, that there's this like LGBTQ. So the question of like identification, that in real life, we are trying to move away from this sort of binary way of thinking to something that is more fluid and dynamic. And yet our computational systems are still so binary. I'm actually curious to hear, how do you see, is there any way out of this? Is there any way that we can actually model something that wouldn't be based on classification, that separate us from the other, but actually blend us into one another?
Yeah, it's a great question, and I mean the short answer is that I think there very much is a way forward. I don't think that it is the case that all machine learning systems are based on classification. There is something about low dimensional spaces, or about reducing the dimensionality of spaces in such a way that they acquire semantic meaning. In language, which is the sort of really special human invention, and obviously long predates AI, language is of course all about classification. So I would say if there's an original sin of classification, it's words, as opposed to machine learning systems. In a machine learning system, we can either reduce things to small number of analog dimensions, or we can classify things into categories, or use language in ways that are more general than just talking about about single categories, but whole I mean, it can, whole paragraphs can be synthesized, etc. So, all of the options are there. I mean, your question is certainly very interesting to me because, a book that I've actually been working on for the last 5 years, really is really centered on this topic. It's called Who Are We Now? I'm hoping to have it out by the end of the year, and it's based on it's not really about AI, but it's based on data science from 5 years worth of fairly large-scale mechanical Turk surveys, and it's all about human identity. The middle third of it is about gender and sexuality, as you raise. To give you a little bit of a sense of what sort of the data science looks like when one applies it to a question like gender, I can show you a picture that might be interesting. Let me zoom in a little bit on it, and then I'll share my screen. Just to make this more concrete. Let's see. Where's the share? Actually, I'm now not seeing the. Here we go. Okay, can you see my screen?
Yes.
So that scatter plot is gender as expressed by people in the responses to several dozen questions. So this isn't deep learning; it's much simpler, but it kind of shows you what the reality is of gender, which is that yeah, it's not binary. And when I say the reality, I don't mean I'm not making any kind of teleology about oh it's chromosomes or it's genitals or whatever. No, I mean I'm saying I don't know what it is. Let's ask a lot of questions and let's look. So this is a two-dimensional projection of the let's look answers from 20,000 people, and you do see that there are, roughly speaking, two clusters that emerge, and the coloring of those clusters is not based on any of the data that actually determines the positions of the points. It's based on what people answer to the questions. Are you male? Are you female? They're both yes/no questions, so they can have 4 possible answers: yes to one, yes to the other, no to both, yes to both. And so green is yes to female, no to male. Blue is yes to male, no to female. Cyan is both. Red is neither. And what you see is both binary and not binary, if you like. You see that there is a clustering, and one of the reasons that genderedness carries such weight is because people do actually cluster pretty well into these categories, but there isn't any excluded middle. People exist in all of the spaces in between as well, and there are people who identify in one or the other way that you can't predict exactly where they fall. So this is in my opinion, this is a questions about human identity are really things that we have to interrogate, right? We have to ask and we have to look rather than asserting. And the kind of unsupervised learning that I've been advocating is really about developing machine learning systems that look with us and that interact with us, as opposed to that impose something from above. And I see machine learning, for what it's worth, as an incredibly powerful tool for offering us mirrors, the ability to understand how we identify, how we talk about each other, how we interact, without bringing all kinds of other assumptions or teleologies into the thing.
Thank you so much.
Thanks, Benas. We've opened up Pandora's box of questions here. I don't know how much time we've got time for, but I want to invite Daniel Bolajan to ask the next question. Daniel is one of the leading AI architecture experts. He's behind the Deep Himmelblau project, and he's doing his research into the work of Gaudi as well in Barcelona. I know your father comes from Barcelona, Blaise. So, Daniel.
Thank you, Neil. Thank you, Blaise, for an amazing presentation. My question, I think, is going to reiterate a few points that Neil was also asking. Personally, my area of interest is mostly focused on teaching machines to be creative and how to augment designer creativity. And I'm really curious about what's your take on that when it comes to augmenting human creativity. And let me just give you an idea where I'm coming from when I'm saying that. So I really subscribe to this idea that also Neil was mentioning, that we can describe perhaps these days creativity as a sort of a form of search more than anything else. Yeah. And I remember also one of your talks, tech talks, where you're giving this example of Michelangelo. Every block of stone has a statue inside it, and it's the task of the sculptor to discover it. Yeah. So I think this applies also to formal domains, not only to creative domains. And we can say that maybe we can understand creativity as a sort of form of meaningful random search. And basically what we are doing, we are just structuring the way we are searching for the right things. Yeah. And also when you think about talent, maybe that's what talent is. Yeah. If we look at it, maybe some people are born in a way with a with the talent into how to shape the direction of their search, of how they search for new things, So probably that's what we can say that talent is as well. But here for me, one big question that's raised there, and I think also Neil pointed out a bit on that aspect of this kind of AlphaGo moves. As designers, in a way, very often we are not aware when we are stuck into a local or global maxima, in a way, in design. So we might generate something that we consider to be creative, but actually it's pretty average, pretty conventional, So for me, then this is a big question then. How can I use perhaps machines to augment that creativity and go beyond these kind of limitations? Probably you're familiar with this idea of the creative curve. So this idea, if something's too novel, we can appreciate it. If it's too unexpected and too unrelated, we cannot appreciate it. If it's too similar, then again, we cannot appreciate it. So there has to be this kind of sweet spot in a way. So personally, that's what I'm looking at, and I'm curious, which is your take there? How can we go outside of this kind of mode of, you have machines that are super creative, but if we as humans, we are the ones evaluating the result. If we as humans, we are stuck into this kind of local minimas, we're always going to evaluate those results as not being creative, perhaps. So what's your take on that?
A few things. So first of all, that idea of the Goldilocks zone, in which something reads as creative and doesn't read as noise or as derivative. I very much subscribe to, and there's a very direct information theoretic analog with that. If you think about music for a moment, and let's just talk about melodic music and think about sequences of tones, of frequencies. The maximum information that can be conveyed would be a random sequence of tones. Right, with no correlations whatsoever. That's sort of the white noise of music, if you like. So that's maximal information, but it's of zero interest whatsoever. Right, there's no meaning in it. And on the other hand, if you just replicate something that has already been composed or played, or make a tiny variation on it, then information theoretically, there's very little there, right? There are almost no bits of information, and there's also no interest. So there's somewhere in the middle. Somewhere in the middle is the Goldilocks zone, and the Goldilocks zone is socially determined in the sense that you have to, and this is where art or creativity is communicative. It has to work in terms of a mental representation that already exists, in the brain of whoever is on the receiving end of that, right? So it has to scan, in some way as poetry, or it has to, sound like music, or it has to, read like a building. There's a use of existing language. It can stretch that language in many ways, but it has to use the language in order to, read as art or as sense making at all. But then it has to also do something surprising within that, within that language, within that domain. So, to me, this is very much at the interface of sociality and information theory. One way of talking about surprise and interest, if you like, is that something that is renderable, that is understandable in the language of the period, and that changes things in such a way that the language will actually, itself change, right? That subsequent creators, artists, whatever, will actually be operating in a world that was different from the one that was there before before you did your thing, right? That's kind of the sign that you've not only broken new ground, but that you've broken new ground that mattered to others. So sociality is really key to that, as is the theory of representations, of something being representable, in the basis or in the language that had already been established neurally by what came before it. Now, the minimization or optimization language that you were using a little earlier, it definitely applies in architecture. I mean, I was very taken with, very impressed by, as I'm sure many of you were as well, the work a number of years ago in which this is not real machine learning, but in which optimization was used in the context of 3D printed forms, metal objects and so on, that would say distribute load, or be tensile elements, in a building. If you want to simultaneously minimize the amount of metal that you use and maximize tensile strength along certain, certain directions, then if you just throw like really serious optimization at it, these beautiful organic forms come out that are they look a little bit like what's in the background over there, Danielle, for you, and look very, very different from a Mies, like rectangle, or something that looks like it came from an old-fashioned CAD system with cylinders and cubes and so on. Those are not optimal forms for a majority of different kinds of tasks that a piece of architecture might perform. I mean, I have a long-standing fantasy that eventually the architecture of the future will be grown and not built, will be self-healing, will include all of the systems for electricity, climate, information, et cetera, that today are not actually thought of as part of those structures, and will be able to digest themselves, when we're done with them, as well as building themselves. So in other words, will be like life. That's not going to emerge in a kind of stepwise fashion from the kind of architecture that that we're building today. It'll require a bunch of pretty profound moves, profound changes that change the game of what architecture is, and don't just make moves within it. And so for me, the epitome of creativity is very much not the surprising move in a game of Go, because the game of Go was already determined. I mean, I know that if you're a real connoisseur of Go, then that whole thing looks like your universe, and there are systems within that, and there are surprising things within it. But for me, from more of a distance, it requires inventing a new game to really qualify as creativity. But that also emphasizes the way creativity is so multi-scale. And the more you know about a thing, the more ways of being creative within it become possible. And the whole process of creativity is very much a wheels within wheels sort of story, in which as an artist or an architect, you're working within a wheel that has as its outer wheels biology and the whole planet, and sociality and all kinds of other systems, and there's porousness between all of those levels as well. So what you do at one level doesn't stay within that level either. It has influences up and down. So I don't know if that was a useful answer, but I'm looking for things not only that surprise me in a genre, if you like, but for things that change my representations and my sense of what the game is.
But here, to expand a bit on this idea of augmentation, how can you enhance human creativity? Because for me, that's really the big question right now. The office that I'm working with in Vienna, we are developing the networks. So it's great if you have one designer being able to operate the network. But the question is then, okay, how we distribute this to our designers now in the office that have no idea about these networks?
Yeah.
And how can we go beyond, that kind of limitations that we as humans, we always, we are born with that. Yeah, like Derrida is talking about this idea of, we have a sort of frame of how we see reality, or how we perceive reality. So for me, that's then the interesting thing of AI, because we can generate these kind of images. For example, for our principal Wolf bricks, these kind of images are more inspiring than for other, employees in the office, because each one of us, we have our own, filter, how we interpret, things. And for me, that's a really interesting question here. Like, how can you almost like open the eyes of somebody to see the potential in that? Yeah, because otherwise, all these machines, they are fascinating. They're super sophisticated. They might engage in a very, very sophisticated process. But if you don't have a human capable to evaluate the result correctly, or to evaluate the quality of that result, then in the end, it's going to be considered or dismissed. Yeah.
So we don't have machines today that are fully fledged social actors. They still have to. They're still doing sort of tasks that are fully defined. Not non-creative, or are, you know, and I'm talking about conventional sorts of computing tasks now, or they are, you know, in the service of people who are doing the creative work, and setting up the game, and you know, then you know, it looks like little more than optimization, right at the moment. I don't think that will still be the case in 10 years' time. And this is, I mean, who knows, right? I mean, I'm making now a bet or a wager, and you know, we'll see how this works out. But I suspect that when another decade has passed, we will be in a time of you know, where the actor network includes both people and machines, and I think that's actually really important in a number of senses. I mean, one is that if we think about a sort of, you know, upward spiral of progress and of invention, a lot of what has driven that upward spiral so far really is just rising population of human beings. You know, every one of us is a site for the recombination of ideas, and you know, the super exponential has everything to do with the number of ideas in the air growing and the number of sites where those ideas can be combined also growing exponentially. You know, human population is going to peak and start to go down, as it must. You know, a big question in my mind, to go back to, you know, the very first slide that I showed, is, you know, does that mean that progress itself, you know, is an S curve and will you know, will peak and slow as the human population growth slows, which I think there are signs of that happening now. Well, not necessarily if synthetic minds are also locuses where ideas can recombine, where judgment can happen, where social interactions can happen, you know, so in that sense, I think that what we have, you know, I won't say what we've started, because, you know, it started on Earth billions of years ago, but the thing that we've been a part of, right, this sort of growth of complexity and invention and sophistication and beauty and so on, is something that will continue to happen both in human minds and in machine minds, which, you know, I would prefer to interpret the whole thing, if you like, as humanity. I mean, I'm sort of with Tim Morton on this. He wrote a book, Humankind, a couple of years ago, in which he talks about expanding what we mean by humanity to include, you know, all of the biological and animal, you know, other organisms on Earth, and the microbiome and everything else. And I fundamentally agree with that. I think that, you know, if we're going to talk about an us without a them, then us has to include the microbiome, and it has to include AI, and it has to include non-human actors of all sorts. You know, and the moment we can think about that as not other, I think, you know, we're going to be able to start to you know, make progress again. Obviously, there are technological developments that will determine whether I'm right about you know, AI belonging, you know, in more than an instrumental way, right, in that mix over the next decade. But that's my suspicion.
Thank you.
There's a question in the chat from Philip Beasley, which I want to mention soon. But before I mention it, there was just one comment going back to the kind of Michelangelo example of the block of marble and the statue coming out. That is to say that Costas Tazidas is one of the computational experts was at UCLA, Harvard, now in Tongji in Shanghai. We had a discussion in Shanghai, and he said basically, or his view is, all the solutions are already out there. It's simply a question of discovering them. And we had a discussion, and he had a plate of biscuits, of cookies, right? And he put one of them, put it behind his back, and he said, okay, just because I can't see it doesn't mean to say it's not there. And you could take that argument to say that actually we're not, actually that's an argument against creativity, to say it's simply a question of searching for that missing cookie, as it were. Which I just want to leave that with you as a kind of comment, but it kind of unties your argument slightly. But I want to bring in Philip Beasley, who I think what you were just saying about kind of living systems and is music to his ears, because Philip is professor in Canada who has a group called Living Systems. He's very much involved in interactivity and all these kind of questions. And one of the leading designers collaborates with Iris van Herpen on a number of different things. So Philip says, thank you for your compelling question of us seeming so often and perhaps pervasively predicting on them. If Western humanist cities have been defined by enclosing walls that are based on just that, the privileged tribe polarized in relation to others outside, then can you share your thoughts on models for public experience and for public space that might seem viable today beyond that preceding binary? That's very similar, in fact, to Banaz's question. Might creative AI be configured to help large-scale human publics, including governments and nations today, to thrive? It's actually in the chat, that question as well.
Yeah, I love the question. I think that it would be, for starters, it would be good for us to remember that the origins of a thing are not necessarily the way that it gets used later on. I mean, we were talking about gender, sexual expression, and so on. Like, when people talk about the purpose of sex, from a teleological standpoint, it's of course it's reproduction. Does that mean that sex is all about reproduction now? Of course not. Right. In fact, the vast majority of sex is not about reproduction, not only for us, but also for our bonobo cousins and so on. And similarly, the idea of the city as enclosing walls and as defending us from them, yes, when we look at the Renaissance origins of at city-states as fortresses, for instance, and one can find the same things, of course, in China and in many other early cities. Well, first of all, that's not true of all cities, even historically. David Graeber and David Wengrow's book, The Dawn of Everything, talks about other sorts of cities, of very early cities that are maybe less discussed in the literature because they're a little bit more enigmatic, but that in some cases represented temporary aggregations of people and more egalitarian ones, and ones that possibly were quite a lot less patriarchal than we imagine. So the idea of a single path or a single route, is probably not right. We tend to sort of simplify these stories and flatten out a lot of the variations that have existed historically. For me, the force that results in cities is less about the walling off of the inside from the outside, and more about the aggregation of people. When one looks at the proportion of people who live in the countryside versus in the city, I'm sure many of you have seen these S-curves. They're very, very dramatic, with the majority of humans on Earth now in cities, where, if we go back, even by 1 century, the overwhelming majority were in the countryside. And remember that, all of that urbanization happened after all of the walls had come down around the walled cities in question. There was a certain point at which walls didn't work anymore. I guess it was, the Napoleonic Wars, or maybe at the very latest World War I, in which the idea of an enclosing wall no longer became militarily relevant. And yet, the period of intense urbanization came along with that. It's really about people coming together. And that force of people coming together has also been an enormous driver of innovation. There are many studies. Santa Fe Institute has done some of these in recent decades that show how when you increase the density of people, you also increase the rate of innovation and the rate at which new ideas are generated, and the productivity in terms of patents and in terms of art and so on. And that's resulting from forces that strike me as even deeper than the sort of schismogenesis or self-other dichotomy. It's the forces of attraction between beings that fundamentally are all about modeling each other. A being that models other beings wants to be with other beings to model. I have a theory. It's maybe it's a little bit crackpot, but in the political polarization that we've all been seeing intensify over the last 5 years or so, the schism between the countryside and the city is I think the widest. Not between one city and another city, which is the story that we had, in the Renaissance city-states, but between all cities and all countrysides. In all of the electoral maps in the U.S. In the last couple of presidential elections, there are no, red states and blue states. There are rather blue cities and a red countryside. The same is true in Europe of a lot of the political disagreements that we have seen lately. And I think even in China, although politics is a little bit more difficult to sort of quantify in that same way there. And I think the reasons are fundamental. They're because the people who aggregate into cities progress faster than the ones in the countryside. And it's almost as if time is flowing at a different speed in the city than in the countryside. And this will progressively pull the city and the countryside further and further apart. Progress feeds on progress, and so you get a schismogenesis not between cities, but between all cities and all countrysides. And of course, in the politics of most places in the world, the countryside is afforded a bit more political power per capita, sometimes a lot more political power per capita than the city, because political power is some kind of combination of per capita power and per acre power or per hectare power. I think that's beyond just the simple dynamics of inequality. I think that those city versus countryside dynamics are driving a lot of the problems that we see right now. And I feel like as urbanists, addressing that central problem would be the single biggest contribution that you can make beyond of course ecological concerns.
Blaise, we've got 3 more questions. I don't know how much time you've got. I mean, you've been very generous so far.
It's Sunday, so I had something else to do at the beginning, which was sleep. But by now, I have nothing else to do other than get my coffee.
Okay, so we've got 2 from the chat and one from one of our group here. So the first one is from Son Interior in brackets Dylan Andrade. Don't know who that is, but hi, I'm really enjoying the session. Thanks for sharing. Several comments like that, so thank you so much.
Me too.
I want to ask, what are the role of emotions when we try to understand what is intelligence, creativity, and empathy, and if there is research in this sense mixing AI, neuroscience, and architecture?
Yeah, it's a great question. I mean, there is an entire field of AI called affective AI, and emotional AI. Some of it is geared, much of it is geared toward the problem of making AI systems that can recognize emotion in humans or affect in humans. There's a big difference also between affect and emotion. Usually it's described in terms of affect being communicative. Affect is what you're putting out, and emotion is what's inside. The dichotomy is of course not perfect, because often what's going on inside is getting put out in one way or another. And the two influence each other in interesting ways, and we are not always conscious of all of the ways in which those things influence each other, or the way we influence each other socially. So it's an area that has come in for a fair amount of anxiety and concern, because the question why would we be making machines that that are good at reading human affect or emotions, can be answered in a lot of ways that are not particularly great, like advertising campaigns, or sort of automatic Nielsen ratings for everybody with front-facing cameras or something like this, and that feeds into a surveillance capitalism narrative that nobody is very excited about. It's come in for a lot of critique, and in some cases rightly. At the same time, emotion and affect are both really fundamental to human sociality, and in that sense, it's not possible for us to train machines, even in an unsupervised way on outputs of human civilization, or human language or whatever, and not be training them in affect and emotion, because that's intrinsic in all of those media, in all of that information. So. I think that in that sense, the difference between affective computing and non-affective computing doesn't exist the moment we move to unsupervised and free-range kinds of models, and affect is just one of the many, many dimensions in all communication and sociality. At a somewhat deeper level, emotions are the motor. Per Jeremy Bentham, they're the springs of action, the things that drive us. I'm not a utilitarian, as Bentham was. I don't think that those things are a scalar or can be summed up, or that the greatest good for the greatest number is something that can be achieved. There are many counterexamples, many proofs why that sort of utilitarian approach doesn't work. But what they all kind of boil down to is the fact that utilitarianism and things like it that try to boil down emotion and goodness and so on to something that can be seen from above, don't recognize that there is no view from above. We're living in a kind of general relativity world with respect to drive and emotion, in which everything is about relationships and graphs, and there's no perspective on that graph that that doesn't privilege one or another actor or look from one or another perspective. So, when we try to think about systems that are going to work well, a lot of this is about trying to include or align with more and more actors, which is fundamentally what the definition of empathy is, right? It's trying to align your own emotional system as an actor with that of all of the others that you interact with.
We have a question from Iman Ansari, who is in the Zoom chat. I think Iman is in Iran, and I'm thinking Isfahan. Maybe I'm wrong. Iman, would you like to ask your question?
Hi, yes. Primarily, thanks for your great informative presentation. I have two questions. First of all, do you see open source platform like Hugging Face or any other platform in transfer learning more as a democratizing tool to enhance creativity on individual level, or more like controlling tool in the hand of few? My main concern is with the emergence of GPT coding and all the computational resource needed for training ML. I think it's not applicable as an individual level. And to further on the notes that Neil has made too, in general, we are getting closer to artificial general intelligence or distributed artificial intelligence? And how do you see the role of us as an architect in this transition? Thank you so much for your insightful presentation once again.
Thank you, Iman. Those are really great questions. I mean, the second one briefly. I mean, I guess I've answered yes. Throughout much of the talk. Yes, I think we're getting a lot closer to it, and yes, I expect to see a lot of the naysayers, proven wrong in ways that are pretty hard to discount over the next 10 years. Although maybe I speak too soon, not in the sense that that I'm going to take back my my own claim, but the degree to which people are willing to discount the evidence of their own eyes and ears in favor of a political position, or the degree to which we are very, very concerned with defending our human exceptionalism and uniqueness, or the degree to which the politics of identity, in a way, trump any other considerations. Those may mean that we're still having debates about this question of general intelligence long after I feel like the evidence is completely settled. But but that's just me. To the first question about democratization, there's been a lot of talk about GPT-3 type, and next generation models of this kind being very expensive to train or to pre-train, which is to say, do the unsupervised stage of the learning, which is 99.99% of it, and also the models just being very large. And those things are both true. They set records in terms of size. They set records in terms of the amount of pre-training data they consume, and they set records in terms of the amount of energy that it takes to do that. Some of the more some of the higher estimates about how much energy they take to train are pretty far off, because a lot depends on the details of where and how those are being trained, and also, frankly, where the data centers are, where they're being trained, and what the usage patterns look like of energy there. There's a fairly detailed analysis of this in a paper that Jeff Dean and Dave Patterson wrote about a year ago, and it's worth a look. Also, though, we're not done, right? Those pre-trained models will continue to get even bigger. Pre-training them is energetically non-trivial for sure. However, there are some pretty important respects, I think, in which stuff is going in the opposite direction, toward democratization and broad applicability and very low power. And that's also maybe concerning, by the way, because these systems can be used to do all kinds of things that we might argue are weapons grade and are dangerous to let into everybody's hands. But let's set that aside for a moment. The thing about pre-training a model like GPT-3 and what have you is that the pre-training is not task specific. It's for any kind of language related task. In other words, you're not doing the training again and again for every application that you might imagine. That is general purpose and only happens once, which was the big insight. And what that means is that one company or one government or one nonprofit or whatever can pre-train the model once, and then anybody can use it for doing anything. And the amount of supervised data that you need in order to make it do a specific task is tiny compared with the amount of pre-training data, because it has learned to generalize from that vast amount of pre-training. So that actually opens up many applications that would have been impossible before, because we don't have enough training data. And the many individual actors who want to do things that they're not able to procure a million samples that I talked about earlier, right? That becomes possible for them to use this. Even the pre-training data, by the way, has been democratized to a surprising degree by things like commoncrawl.org, that sort of scrape and archive very large parts of the internet and clean it up and turn it into into packages of pre-training data that anybody can access. So the kind of gatekeeping quality that big companies used to have, I would say, in the in the kind of deep learning era, is very, very rapidly eroding, because even though the models are very large, the training and the distillation required to turn them into task-specific models, small models, is more democratically available than it ever has been before. And that actually worries me a little bit, to be honest. I mean, I thought that the decision OpenAI made to not make the model publicly available when it first came out was, I mean, I'm troubled by that decision. I'm troubled by its implications, but I also was relieved, because things like disinformation made by large language models strike me as much more powerful than visual deep fakes made using very convincing GANs, for instance. Most of us get our information and interact with each other via texts, and the power of something that could be infinitely replicated and be made to generate infinite numbers of texts and things. I mean, that's I don't know if that's something that we want unfettered public access to. So I don't think we've figured out as a society yet how to think about democratization and access control of those kinds of technologies, and I think that's a pretty important question. It seems a lot harder to me than nuclear materials, where it's very easy to to control where they go, or than say gene editing technologies, which despite being much more democratized nowadays than they used to be, still require a serious lab, right? But this stuff doesn't require a serious lab. This can be done with with a laptop. So yeah, I don't know how to think about it, but I'm a little concerned about universal access to being able to do anything with in particular large language models.
We have a question now. Thank you, Emma. We have a question in the chat from Janine J. Label, I think. I'm not quite sure the name. Great session. Measuring the level of creativity from either human or computational perspective is still an open question. Though we have product-oriented criteria like novelty and usefulness, the process of creativity seems missing from these criteria. Can you comment on this issue a bit, especially the measure of creativity from the computational perspective? Thank you.
Sure. I don't think creativity can be quantified, point blank. I think that any measure that one proposes, one can always find some creative way to circumvent, right? To say, well, here's a really cool thing that has creativity 0 according to your measure, or whatever. So yeah, I just don't think I don't think that consciousness, creativity, or many other properties that are kind of dynamic and social judgments that we make intersubjectively, if you like, can be quantified. That doesn't mean, and I hope this is clear from everything else that I've said, doesn't mean that I don't think that those things will be getting done by computers as well as by people in the future. Just that the idea of a global measure or of this being a utility function that can be maximized, I just don't think is right. It's really all about relationships. And in those relationships, there will be disagreements. As there has always been. Duchamp makes a urinal. Is it art? Is it not art? Is it creative? Not creative? I mean, the whole point is that there's disagreement, and we'll have that sort of thing forever. I mean, we had it. Even in the Artists and Machine Intelligence show at Gray Area, there were very differing views about this, and I think that conversation is great. I am a partisan about some of these questions because, but I'm a partisan as a human being and as a person who is creative in his own right, not as somebody who believes that it would be possible or appropriate for me to try to police other people's beliefs about it.
I've got one question, I think a big question, but I want to ask a very small question first of all. And that is just for a technicality. I'm curious because when you compare Deep Dream to GANs, actually GANs were invented 2014 by Ian Goodfellow, and I'm just curious what happened to the time lag, because I think Deep Dream kind of came on stream about 2015.
Right.
Why didn't GANs get there first? I mean, what happened in the process? Why did we get Deep Dream, not GANs, first of all?
Well, I mean, we get into sort of multiple discovery land as well. Like, there were just a lot of things happening at the same time, and priority is a little complicated with these things. I mean, if you listen to Jürgen Schmidhuber, who has been is one of the very creative researchers in the area, who has been working on neural nets for many years. He always has a like, oh, this was actually invented 10 years earlier by my group. Generally, it's not always his group; it's sometimes somebody else. But all of these histories have all of these ideas have deep roots. So I would be hesitant to put too much meaning on 2015, 2016. Did they happen in the right sequence? Etc. But I would say, the innovation with the GAN was to pit two networks against each other and kind of make a minimum society of two in that way, which is a really interesting idea. And and it did turn out to be the route to making convincing media. There are other ways of doing that now as well, but convincing visual media were first achieved by GANs. The Deep Dream idea was to take networks that had been optimized for analysis, not optimized for making media at all, and just doing the optimization process on the pixels themselves in order to maximize activation of some node or other in the analytic network. And so it's unsurprising that the result that you get from those things is trippy and psychedelic, because it's the network was never designed to make pictures. It was designed to understand pictures. And and then you kind of cook up, well, what kind of medium will activate it in funny, unnatural ways. Well, it's meaningful but unnatural, but psychedelic. Originally, Alex made that in order to more as a neuroscientific tool of artificial nets than as a well, I say than as a creative project. I mean, Alex is a very, very creative person, and everything he does is a creative project in one way or another. But he was thinking about it more, originally I think as more of a diagnostic tool, and then was kind of startled by the beauty and the strangeness of what came out. But yeah, the goal was, what activates this neuron or that neuron. There are also people who believe, Eb Fetz at University of Washington, neuroscientist, and I share this belief as well, that the trippy, hallucinogenic or psychedelic quality of what Deep Dream creates is not a coincidence. That sort of top-down activation of networks designed to understand rather than to synthesize is what gets lit up by psychedelic drugs in our own brains as well. So our own visual cortices and sensory cortices and so on are designed to analyze, but they have lots and lots of recurrence, lots of top-down connections as well in order to enact top-down attention. We don't. I don't want to pretend that we fully understand how it works either, because we certainly don't. But one theory, one idea about what psychedelics do is to mess with the balance of bottom up versus top down in such a way that you get a deep dream-like effect.
I think that's Anil Seth has been doing some research in that particular area as well.
Yeah, and we agree on that as well.
Let me just finish off with one final question, but I think it goes right to the heart of something we're discussing today. I came across this quote from Larry Page, co-founder of Google. AI would be the ultimate version of Google, the ultimate search engine that would understand everything on the web. It would understand exactly what you wanted, and it would give you the right thing. We're nowhere near doing that now. However, we can get incrementally closer to that, and that is basically what we work on. Is that fair?
Yeah, I think it undersells or understates what we're working on, to be honest. I mean, I'm personally interested in a lot more than a better Google search engine, but it is certainly the case that that a rich language model, a large language model, plus a more than language model that can understand all of the video and all of the other stuff that is on the internet, would do a much better job than what amounts to a keyword searching engine, of harvesting stuff for you. Yeah, I mean, I would very much like a research assistant that had read everything on the internet and could locate all of it, as well as answering subtle questions based on it with citations, right? But that would involve judgment, reading between the lines, and so on, and understand things that are not so amenable to simple keyword searches. So yeah, I mean, of course, the kind of learning, especially the language-oriented learning, that's really been the feature of the last several years, and it's developing very rapidly now, will massively improve search. But I also think that the idea that is very grandiose. I guess, I mean, I really want that, but to me, it's just a tool among many other kinds of tools. And also, there's a little bit in what Larry said there, I think, of mystique about like give you what you want, even when you don't know it, or even before you want it. Like there's a little bit of that sense of I don't know, of something more or different from a search engine that I'm not sure I agree with. I would rather think about the AIs that we make as participating in social networks with us. For a variety of different reasons, for all of the reasons that we participate with each other in social networks, as opposed to some kind of magic that predicts you or knows you better than you do, or other kind of stuff like that. It sounds a little like the social dilemma fantasy, and as opposed to just the obvious utility that a large language model able to read the entire internet would give. So yes, but to me it's a lowball answer.
Thanks, Blaise. I think in some ways that what we've done today on this platform is, in a sense, articulate your comment about the social network, how you think through each other. And I just want to point out from a kind of a pedantry point of view, that the word compute is the Latin. Latin means to think together. Computare means to think together. And I really get the sense that that's exactly what we've been doing today in the most incredible way. And I think we've opened up a Pandora's box of questions that will go on from week to week, and it's really been an incredible springboard. I want to thank you, Blaise, for this remarkable session, and the comments coming in have been really amazing. So this is, in a sense, we're coming to the end of the session, but it's almost like the beginning of something else, some other discussion. I want to just quickly put up on my screen, just so everyone's aware of that we have next week a session with David Chalmers, whose book Reality Plus Virtual Worlds and the Problem of Philosophy came out last Tuesday. So please read it, and we'll talk about it next week. Joska Bach will be following, and an astonishingly interesting person in himself, plus Jeffrey Hawkins, who I think will respond and will in a very interesting way to what Blaise has raised today. Many things in his work. There's Andy Clark, there's Antonio Damasio, there's Susan Snyder, and hopefully Anil Seth if he recovers in time as well. This has been a fantastic session. Thank you, Blaise. Thank you for your generosity. I think that we've reached out literally over the world today. I mean, amazing. And we'll put this up onto our YouTube library for the future. The whole principle behind our digital future thing is to try and democratize education by making things available, so it'll be there for the future for everyone to talk about. And this, I think I sense right now that we are touching on, I mean, I speak as a theorist, primarily as a theorist, one of the most interesting moments, I think, in the history of kind of theoretical debates where we get this convergence, and it really is provoking lots of interesting kind of questions. And more than anything else, Blaise, in the discussion today, I got the sense that really something that I've often thought, really, that AI can become a mirror in which to think about what it is to be human. And the questions really were more about being human than to do with AI itself. But it seems to me that AI opens up this question and forces us to reflect on things in the most provocative way. I've never experienced this moment, not even back in the kind of the post-structuralist kind of frenzy of the 90s, when these things are really going to open up debates. And I would also say that alongside that frenzy in the 90s, which led to a huge amount of architectural productivity under the work of Deacon and so on, the work of Zaha and Frank Gehry, and things came out of that. I'm hoping also this might produce a whole new kind of domain of thinking about design itself. And I think we've had here some very talented designers being part of this. Thank you so much, Blaise. This has really been terrific, and thank you for your generosity. It's very much appreciated, and let's hope we can continue the discussion in some way, in some future way.
Absolutely. I agree with everything you just said wholeheartedly. I also think it's a very exciting moment. Thank you all so much for your wonderful questions, and for having me on, and for being here for 2 hours 48 minutes. That's an impressive session. And yeah, let's continue the discussion in all the other fora. Thank you all so much for having me.
Thank you, Blaise.
Cheers.
Thank you, everybody. And thank you to the team that put this together, behind the scenes, Digital Futures, Gustavo, and so on. Thank you so much. And see you next week. Thank you. Thank you.